Feingold in UCLA showing unique populations of Clostridial bacteria in the digestive tracts of these children with regressive autism.
Dr. McFabe realized that one of the byproducts of Clostridia is a short-chain fatty acid called propionic acid. It's not a neurotoxin, but it does have dramatic effects.
And then in my previous work, we were working with this compound, propionic acid, and we found that for such a simple molecule, it had very widespread effects in the central nervous system, affecting brain development, metabolism, and immune function. And then, we sort of put two and two together, and we said, hey, these bacteria in the gut, when children eat carbs, ferment the carbs and make propionic acid. And in addition, some of the foods that these children craved, in addition to being high carb, did in fact contain propionic acid as a food preservative.
Propionic acid is labeled on food packaging as E280. It's a commonly used preservative in many bread, cake, and cheese products made and sold throughout Europe, Australia, South Korea, and North America.
So we thought to take propionic acid and give it in small amounts to rodents and see if the behaviors or brain changes looked anything like autism and whether or not these behavioral and brain changes were transient.
Dr. McFabe's control subjects exhibit typical behavior. Rats are highly social animals. They greet by sniffing nose to tail and interact as they explore their surroundings. But when a propionic acid solution is introduced, this all changes.
What we noticed remarkably within 2 minutes of putting this propionic acid in, this animal immediately starts exhibiting some very peculiar behaviors. Obviously, he's hyperactive and moving very quickly, and then repetitive behaviors. Here you see an abnormal posture of walking with a hunchback. And it's an unappreciated part of autism in that patients often have toe walking, abnormal posturing, arched back. So now we'll place another animal that's been given propionic acid. And a peculiar thing happens. They show none of the normal social greetings of two rodents seeing each other.
A video tracking system records and compares the obsessive and antisocial PPA-treated rats with the normal rats. Other experiments showed responses such as rigidity and object fixation, and the intriguing fact that the effects of PPA wear off.
So now we're about a half an hour after we've exposed these two animals to propionic acids, and their behavior afterwards reverts back to normal, and it's a fat, so it's burned through metabolism. The animals become more social. Usually after their escapades, they tend to just go back to sleep. So again, we have a reversibility of hyperactivity and a reversibility of social behavior.
The autistic-like behavior of PPA-treated rats was compelling. But Dr. McFabe and his team wanted to know exactly what PPA was doing to the brain.
So do you have the lipids on the PPA rats?
Yes, here it is. This is what the final product looked like. When I finish this analysis, we'll be able to quantify whether or not there's any alteration in any of these components.
Brain fat composition is intertwined with behavior. So Dr. McFabe is working with lipids expert Dr. Ray Thomas, who's been examining PPA's effect on lipids, the fats that fuel brain cells.
What we've found is that when we give propionic acid, which is a metabolite from enteric bacteria, it has the propensity or the potential to alter brain fats. They alter the omega-3s, the omega-6, the saturate level. And these alterations that we've found in the brain is closely related or similar to what has been reported in the blood of autistic patients.